today's mini project will be based on the correction of digits. All right, so it's a regression problem. So first, let's create a script for that purpose. All right, so it ENN digit correction. Okay, so as usual, we'll start with the clearing and closing the various windows present, unwanted windows from the previous code run, and then we'll clear the screen. So that will be the first section. Then we load the data. Okay, so the data is actually directly present in the Matlab. It is one of the examples in the Matlab. Okay, so the code which I'm going to give, it's already in Matlab, so it's a existing code, right? So I'll just teach you how do we use that. Let's load the data now. So data can be loaded directly as X string. Then I'll also load the Y string is equal to, it's called as the digit, the data which is already present is digit string for D array data. So this is actually already present. So let me run and show you. So as soon as I run that, the X train, Y train comes into picture. Okay, so you see X train and Y train directly came into picture. Okay. Similarly, I need the validation of the testing data as well. Okay, so that is X test and the Y test. For testing, it's actually present in a different format, different file. So that is digit test 4D array data. All right, so now when I run, I'm expecting X train, Y train, X test as well as the Y test. Okay, so let it run so that we get this. Now you see, right? Okay, so I wrote it as a B test. Sorry, this has to be Y test. All right, so we loaded the data. Now I want to see what is my data, right? So I didn't define the problem today because as of now, until and unless I show you the data, I will not be in a position to uh, define what is a basic problem here. Okay, so I didn't define the problem because of that. Now let me display the data first, right? So that is number of training data. Actually, this is a image data. So okay, so training data is equal to numerical length of the Y train. Whatever is the length, that will be the length of the data. Okay, so many we have, that's the length of our data. Okay, so let me load this. Now I don't want to keep repeating that again, so I'll just run this. So you can see that there are 5,000 training data, out of which I want to plot something and see. Okay, so let's call it as a figure. Let me define the index value, that is equal to, you see, randomly I'll generate, right? So how do you create a randomly generated numbers up to a limit? It's a by doing a random permutation. We already have used this particular command several times. Okay, right. I have to tell, right, what is the number, what is the maximum number. Maximum number is equal to the number of training data. Within that, any number should be fine for me. such how many numbers I want to generate. I want to visual. So let me assume that out of 5,000 different images, I want to see, say, 30 images. So let me make it as strictly 30. Okay, I want to generate 30 random numbers. So that is the index. Let's see, right? When you run this, you will get the index. If you open the index, you see randomly generated numbers are there. How many numbers you have? You have 30 numbers, right? What is the highest number possible is 5,000. Any number within 5,000, you make it here. Okay, so that's what is the random permutation is going to do. Right, so we did that. Now let's try to plot. So I'll call the figure later. Figure is not required here. So now I'll go for the plotting. So before that, I need a figure. So figure. In the figure, let's go for a. Okay, I want to plot 30 images. So for say I is equal to starting from 1 2. I opted for 30 images, but this can be changed, right? You may okay, I'll create a variable here. So that is number of plots equal to 30. Now you see, you may change this at any point of time. So this will be num plots, right? So I is equal to starting from 1 till this, till the num plots, number of plots, right? So many. What do you do? I want 30 images, correct? So all the 30 should be plotted in the following fashion. Go for a subplot. That's a better way. Subplot. Let me assume that I am trying to write. So 30 images. So 6 rows, 5 columns. All right. 6 comma 5 comma I. Ith position you are trying to plot. Subplot at this location. You are going to do a I am. You are going to show an image, right? Because this data is image. Every data point is an image, right? So I'm trying to plot that. I am show the X train data. As you can see, X train is a 4-dimensional data. Okay, so 3 dimensions are plotted as they are. So that is column, comma column, comma column. Then I'm going to say that which is the index. Okay, index of I. That's what I'm trying to plot here. Let me go for end. Let's check whether this is going to work. All right, so run this section. So I should be able to see 30 different images on a graph, right? That's going to come, right? So can you see, right? 2 1 4 8 8 1 4 8 1 0. So you can see that this is a handwritten digit data set. Okay, but the important thing to note here is that every digit is actually tilted, right? The orientation is not proper, right? They have been tilted by a certain amount of angle. They have been rotated. Okay. So now I define what is my objective today, right? So our objective is that we want to correct this. I want the machine to understand, okay, machine to understand and calculate what is the angle by which a given handwritten digit is rotated. It has to calculate automatically. It has to learn to calculate that. Then it has to apply the inverse calculation and bring it back to the required position, right? So 2 is tilted to the right side. It has to tilt it left so that the 2 becomes proper. Likewise, so for any image I give, it has to do the correction. So that is our objective. We want to teach the machine how to do this. Is it okay? So, right. So that's the data set. Okay. So we loaded the data. We also have looked at the data. Now let us look at the y train, if you see, I'll show you the another detail, because I have to tell the machine that how much is the tilting, right? It has to be given as a training data itself. So you see, if I open the train data, you see it is minus 42, indicating that the first image has been rotated by minus 42 degrees. Second is minus 50, minus 24. So it's everything is given over there. Okay. So you see all the 5000 images have certain amount of rotation, and the rotation angle is mentioned in the Y train. So I use X train and the Y train for the training purpose. Then I do the testing with the X test data, right? And I'll compare the result with the Y test data. Okay, that is present. That the machine gives us. All right. So for that reason, what I do now, I'll split this into a new thing. I'll split into a new. Okay, so let's plot once again, just to see that what are the various rotations we have in our image data set. So I'll call another figure, and let's go for a histogram, because histogram is going to give you the clear cut detail of the y y train. So I know that y train, t train, this is y train, because y train is angles, right? So it, you will get a clear cut idea that okay, what is the range of rotations you have in your image data set. Okay. Then y level will be the count value, and the x level is angle of rotation. Okay, so let's try to run this section. We should be able to see it, right? You see, this is what? This is a histogram. It very clearly shows that we have the angle of rotation up to minus 50 degrees, right? This value, right, 296, right? Data has, sorry, 296 of them have angle of rotation between minus 40 to minus 45. So minus 35 to 40 is 280 values, like that. You see, right? Various rotations are possible. So plus 40 to 45 degrees, you have 342 data, right? No rotation also, you have a data. Okay, 264 approximately. Like that, you have the variation. You can see that, right? We have the rotations possible in all the possible directions, all the possible angles from minus 50 to plus 50, let's say. Okay, so we have the data. So data set is ready. You don't have to do anything. So what is our next objective? Define the neural network. Okay. So let's go to the deep neural network design part. So start with the defining of the layers. Okay, so layers is equal to, let's try to start with. So what is your input? Input is a image. Okay, so input is an image, means I should be able to get the size of the image, right? So what I do, so input size, or I can use the size directly over there. Okay, that is what's the first layer? It is image input layer, but I need to specify what is the size. So that is the size of, right, which is my data, x x x train of right? I'll go for the maybe one of the image. Let me check that whether this works as it is in the command window of the first one. If I calculate that, do I get? It says just 1 into 1. No, that's not the way I want. I want all the rows, all the columns, and all. Oh, sorry. This has to be like this. Let's check. All the rows, all the columns, and the third dimensions, and 1. Yeah, this is 28 into 28. Okay, so 28 by 28 is this size, and the third dimension should be added to this. So how do we do that? Okay, let's try to do this. Yeah, 28, 28, 1. So this is what I want. So input layer of this size. So you understood, right? What's happening, right? So this is the size required, 28 into 28 into 1 dimension. It should not be more dimensions, right? I should not make it 3 dimensions. So I'm specifying that I need 1 dimension. So that one has been concatenated over here. Okay, so that is a image input layer. Followed by that, I will go for a convolutional. Convolutional 2 2D layer. So you have to specify what is the size, right? What's the how many such filters, and do you need a padding? You have to specify, right? I'll do the padding in such a way that the result is of the same size. Okay, so that's a convolutional. What follows the convolutional layer? If you remember, it has to be the batch normalization layer. Okay, you don't have to specify anything over here. The specification is required. Go for the activation function, that is ReLU layer. Now what I do, I'll show you a new thing. There is uh, instead of doing the max pool, I do the average pool. So pooling can be done in any possible fashion, right? So I just want to show you the other one. So I'm writing this. This is average pooling. Average pooling. It's again it happens in 2 dimensions. So average pooling 2D layer. Okay, so whenever the pooling happens, you need to specify the size of the pool, right? So that's 2 cross 2 matrix. Then you have to specify the stride, how many jumps you want to do, right? Once a data point has been used for the pooling, I don't want to use it for the next pool, so you need to skip that by making it at least 2. Okay, right? Fine. So now you see, I want to repeat this few times. So up to the average pooling. So I'll copy this. So my next layer will be once again the same. Okay, these 4 lines will repeat, but I'll try to write it as a different category. So this was the first set. This is the second set. So convolutional 2D layer. When I'm going to use, I'll change this to 16. Okay, so padding remains same. Then you go for a batch normalization layer. After batch normalization, we'll have the ReLU layer. Okay, ReLU followed by the average pooling layer. All right. Once it is done, now see, I'll repeat further because this is not going to work if I use a lesser number of layers. So we need to increase. So what's the change you are expecting? This is 32 or 16 earlier, so double that. So that becomes 32. Okay. Then you have a batch normalization layer followed by the ReLU layer followed by the convolution. Followed by ReLU layer. Uh, okay, let's make a change. Now what I do, after this ReLU layer, I'll go for another convolutional layer. So you are free to make the changes as you require and do trial and errors. Okay, so please do that. Then only we'll be able to learn or explore more things. You see now, I'll go for the batch normalization. Oh, I'm repeating the same thing, right? So this, I'll not do the average pooling again. That's all. Okay, so convolutional layer. So since I'm not changing the convolutional layer size, right, I don't have to do the average pooling again and again. Okay, all right. Let me put the average pooling layer here. Okay, we got a ReLU layer. Now I go for the dropout. Dropout layer of I don't want to go for a bigger value. If you remember, the a small portion of the layer weights will not be updated in the during the dropout. So you can assign this as 0.2. So 20% you uh, drop it. You don't consider for the weight updation. Then you go for the final, that is a fully connected layer. Right. So how many outputs you are expecting? I'm expecting only one because my calculation is just one value, that is an angle, right? So fully connected layer of size 1 and do the regression layer. Is that okay? So that's how you define the layers required. So once the layer is once the layer is defined, let's go for convolutional 2D layer. Some mistake. Okay, so line number 35. So what's the mistake? If you remember, it's not convolutional, it's convolution. So the same error will come here. Convolution. Okay. Just a second. Let me delete the layers once. Okay. It was giving error because I gave a space. Sorry. Now let me check. Now once again it's the same. Okay, let me run from the beginning. Maybe run some other mistake. Layers is equal to line number 33. Okay. Okay, so I actually missed this, so because of which it was throwing up an error. All right. Okay. So now in the next part, I am supposed to give my options. Okay. So training options are what I'm expecting. So the function is by the same name, training options. Okay. Give any preferred algorithm like ADAM or SGDM. Then go for mini mini batch size. So normally mini batch size can be any number. So you can give preferably a 2 to the power number. Okay, so maybe I'll give 64. Okay, then max number of epochs. Maybe I want to go up to maximum of 100, let us see. All right, then what we'll give the initial learning rate. Initial learn rate is say 0.001. Then we'll specify the learn rate schedule. So the learn rate schedule, how do you update? It is piecewise. It's a piecewise updation. Okay. Then by what factor you want to update your learn rate? So that will be that can be specified by using learn rate drop factor. So let's specify that by as say 0.1. In the sense it will be multiplied by 0.1 every time you want to update. And let's say that that happens somewhere around the 50th iteration, because totally it sorry 50th epochs, total epochs 100, somewhere at the middle I try to drop the factor by this number. Okay, so that can be specified. Drop period, learn rate drop period. I'll write as a maybe 50th epoch. It will change the learn rate. Then I want to shuffle every epoch. I want to every epoch I want to perform the shuffling of my data set. Then let's go for validation data. Validation data will be same as my training data. Okay, so I will this way. So that is x train comma y train. So you see here, if I don't want to, if I want to test during this process itself, I can do that. Okay, so it's possible to do that, but we'll not do it here. I can simply give the validation data as a testing data only, so that validation, whatever accuracy we get, that becomes a testing accuracy. Okay, so that is possible, but anyway, let's go with the conventional method where we test at the end. Okay, so validation data is there. Then I want to specify validation frequency. Validation frequency. Say maybe I'll just give us a 10 or maybe 100. Mini batch size is 64, so maybe I'll check at every 128, double of that. Let me check. All right. So I learn two things and I test once. So that's what is the meaning. Validation frequency is over. Then go for a plots. What do you want to plot? Training progress. So the training progress followed by, I will say that I want a verbose. Okay, just to visualize the training progress in the form of a table. Right, so I'll say 1. Or you can write true over here. Okay, so let's work. Now let me try to run this section. And yes. And now let's go for the network, the trained network. I'll directly go for a train. Okay, train a network with the following data: x train, y train, then the layers defined and the options. Okay, right, let's try to run this and check whether we get optimized network. Okay, so the training progress begin. We can see that in the command window in the form of a table. So we can even see the training progress at the top.